So in this video, we'll be discussing about what are coil losses and what is all about loaded and unloaded Q factor of a tank circuit. So this is an initial part of our tuned amplifier discussion. So what is a tuned amplifier? Okay, so this, as a name states, so this helps us in amplifying a certain ranges of frequency in the radio frequency region, and it helps us in obtaining only a particular frequency of radio frequency, and it helps us in it allows us to reject all the other frequencies. Okay, so the amplifier which helps in selecting only a selected range of frequency, that we call it as tune circuit. This is actually working as that how we tune an AM or FM station in our radio devices. So how do we tune with the help of knob, and we select a particular radio frequency range. So this is actually the same similar kind of one. So which where when we want to tune to a particular range, we follow certain several steps to obtain that particular frequency region, right? So the same way this amplifier also works. uh, um, this amplifier in construction, so it has a coil and a capacitor that is being connected in series or in a parallel. So whenever the characteristics of this inductance or a capacitance that is being found in this tuned circuit, we term a phenomena called resonance that takes place. So what is resonance? Basically, a resonance is one that helps, or that is a phenomenon of increased amplitude, so that occurs when the frequency of an applied periodic force is equal or close to the natural frequency of the system in which it acts. So this is a resonance definition. So how does a tuned amplifier looks? Okay, so you can see from the figure the tuned circuit, where you have this capacitance, inductance and resistance that is being connected in the circuit, and this tuned circuit, which we call it as a tank circuit in all our discussion, and this tuned circuit will be employed in our amplifier circuit whatever we are about to design, and we'll be discussing more on other things actually. Okay, so before we go into the actual design of tuned amplifier circuit, so there are certain losses that is being associated with this system. Okay, so there are three losses. One we call them as a copper loss, second is an eddy current loss, and third is a hysteresis loss. So total loss in a tuned amplifier circuit can be given as a sum up of copper loss, eddy current loss, and hysteresis loss. Okay, so copper loss is the one that is greatly or inverse depends on the frequency, and it is inversely proportional to the frequency of the system whichever we give. So once the frequency increases, this copper loss decreases. Okay, so eddy current is another form of loss. It is due to the current flow in the copper coil, and it is directly proportional to the frequency. So hysteresis loss is the third one, so that is proportional to the area that is being used in the design, and also in the rate at which the loop of the circuit that is traversed. So the second important criteria of this tuned amplifier is a Q factor. As the name states, Q is nothing but a quality factor. So this is actually an important character of an inductor, and it also defines what is the ratio of reactance to the resistance. Okay. So this is a one more definition of an Q factor. So in layman term, we can tell Q factor, it's gives us an information about the purity. Okay. So we can define Q factor by Q, whereas Q is equal to 2 pi into maximum energy that is stored per circuit divided by energy dissipated per circuit. Okay, so this is the basic information on the quality factor, and there are one more definition that we call it as a dissipation factor, that is related to the total loss within the component, and that is given by 1 by Q. And quality factor equation Q can also be given 1 by dissipation factor. Okay, so you can see when where you have this resistance and inductance, how does it look when it is connected in a series, and their respective impedance formula. And we have these parallel circuits and their circuit with inductance and resistance in a parallel, and their admittance formula. Okay, this will be useful for all our analysis part of the amplifier circuits. And these uh, tuned amplifier circuits can be constructed with load and without load. And again, under loaded and unloaded condition, the quality factor comes into play. Okay, so when we have an unloaded circuit, which is nothing but we don't have any tank circuit that is being connected to the load. Okay, in that case, we can measure this Q as discussed in the early 2 pi into maximum energy stored per the cycle and divided by the energy dissipated per cycle in the tank. When we have any tank circuit that is loaded, which means that we have a connected tank circuit to the load, in that case we will be incorporating one phenomenon that we call it as energy dissipated per cycle due to the presence of external load. So we connect an external tank circuit to the load, and we also take up that energy that is being dissipated with that cycle actually. So now the formula for quality, I mean Q factor is given by 2 pi into maximum energy stored per cycle divided by energy dissipated per cycle in tank plus energy dissipated per cycle due to the presence of external load. So we will be considering two parameter in the denominator. Okay, and if we see how does this quality factor varies with the bandwidth, and you can very well see if you have a low response for Q, the bandwidth is very wider, whereas in case of you have high response, which means that high Q systems, the bandwidth is very limited or very narrow, and it tends to be highly selective to the application whatever of interest. So it is always to have higher Q when we construct any tuned amplifier circuit. So with this, we'll end up this lecture, and we'll discuss on the other tuned amplifiers in the next video. Thank you.